So let's talk about configuring IPv4 address and static routing. See, in this chapter, we learn about how to configure IP address on a router's interface and how R1 can ping R3 through R2 in the middle. See, first of all routers maintain something called a routing table that consists of all the destination I can reach. See, if you don't see an IP address in the routing table, meaning that particular destination we cannot reach. That's what it means. So normally a router will add an IP address to its routing table. Majorly we have three different methods. One is called as a connected route. Second is your static route or dynamic route. So one router, inside this we have routing table. An IP can go into the routing table. Either it has to be a connected interface IP, like this physical IP, or we have to configure a static routing using IP route command, or it has to be a dynamic routing protocol like OSPF or something like that. Now, whenever you like to see routing table of a router, the command goes like this. Simply type show IP route. So you take any router and you type show IP route now. That will show you the routing table. Whatever IP you are seeing inside the routing table, only those IPs you can ping. Other IPs you cannot ping. So next is your IP routing. See, the IP routing delivers IP packet from sending host to the destination host. Routing means what? Routing means sending a packet from source to destination, from one place to another place. If a packet is created by an end host as a layer 3 packet, that will send to a default gateway, and through default gateway, this can route based on the destination network. See, if a PCA want to communicate outside the network, it has to go through the default gateway IP only. If PCA want to talk to the local PC, he no need to go through default gateway and all. I can locally switch. With the help of switch, we can go there. You no need to even worry about reaching the default gateway IP. See, whenever a traffic goes from PC1 to PC2, it has to go through each router. And on every hop, the content of the packet will vary. For example, imagine PC1 want to communicate to PC2, and PC1's IP is 20.00, sorry, 10.001, and PC2 IP on the 20.001. Now, from here to here, if traffic wanna go, in that case, in this place, when the traffic is coming, the source IP will be 10.001 and the destination IP will be 20.001. Source MAC will be XX only, but destination MAC will be AA. It will not be this MAC and all. It has to be the next router's MAC address or my default gateway's MAC address. Now, the packet comes all the way to R1. Because destination MAC is my MAC, I will open the cover and I will see inside. And after seeing inside, I see that the destination IP is not my IP. It is somebody else IP. Upon what R1 will do, R1 will first check its routing table to understand if destination IP is there in my routing table or not. Once it confirms that it is there in my routing table, I will find out the exit interface and next hop IP. Then I will send it to R2. See, when the packet travels from R1 to R2, the source IP will be 10.0.0.1. Destination IP will be 20.0.0.1 only. Source MAC will be BB, and the destination MAC will be CC, and it comes all the way to R2. Now again R2 will check destination MAC address. It says that that is my own MAC address only, and I will open the cover. And once I open the cover, I can see inside the destination IP, it is not my IP. It is somebody else IP. And from R2 to PC2, again the traffic will go further. See, in every hop, what is changing? MAC address will be changing. Every hop, something will not change, means your IP address is not going to be changing, because that's a logical address that will not change. It will remain same. And we know already how to configure IP address on the router's interface and all, right? Let's configure an IP address on the router's interface. So I'm going to take R1, R2, and R3. This is R1 router, that's R2 router, that's R3 router. Between R1 and R2, I will use 12.0.0.1, 12.0.0.2, and here I will be using 23.0.0.1 and 23.0.0.2. So first I'll log into my router and I will show you the routing table. Enable show IP route. See, the command to see routing table is show IP route. You enter this command and that's an entire big output what you are seeing here. This is are the mnemonic codes. This code defines how am I learning that IP address. Is it through connected interface or static or IGRP, RIP or what? So this defines how am I learning the, and as of now you can see it is completely blank also. Let's configure IP address 12.0.0.1 on R1. 12.0.0 I have configured. Let's go to R2 and configure same thing. IP address 12.0.0.2. 23.0.0.2. Okay. Now I've configured IP address on all these routers. Now if I come back to my R1 router and type show IP route to see the routing table, here you can see again a lot of codes. See, we have to look below something called gateway. Here you can see C. C means what? Connected. It says that 12.0.0.0 network is connected directly on the interface FA0/0, which is like connected interface. And please remember one thing, routers will never have or store specific IP address. They will not store 12.0.0.1 or 12.0.0.2 and all. They will store only the network informations. They will store only the network information. Okay. Now here 12.0.0.0 is your network ID. See, network ID is very simple. If you keep all your host portion as 0, the remain what you're gonna get is network ID only. So this says that I can ping only 12 network. So you can try pinging 12.0.0.2. The ping will work. But if I try to ping 23.0.0.2, the ping will not work. Why? Because R1 don't even know who is R3. The routing table, I don't have an entry of R3. So how can I tell him to ping? So we have to configure something called static routing. So static routing starts with IP route command. What I will do now is that I will go to R1 and I will tell, hey R1, to reach this network, which is 23.0.0.0, the next stop for you is this IP 12.0.0.2. Same way, I'll go to R3 and I will tell to reach this network, next stop is this interface. So both the way we will tell him. So let's do that. Configure terminal. IP route reach 23.0.0.0, 255.0.0.0. Next stop is 12.0.0.2. Simple. Same way, we have to tell the reverse path also, na? So configure terminal. IP route to reach 12.0.0.0, 255.0.0.0, 23.0.0.1, which is this interface IP, because he knows how to reach him. It is almost like area one, like it's almost like think like Chennai, Tambram Sanatorium, and Krompet, or Tambram, Krompet, and Gindi. How to reach Gindi? You tell him go via Krompet because he knows Krompet. For person is Gindi, tell him Gindi to go to Tambram, go via Krompet, like giving the path only. Now, if I come back to my R1 and if I check my routing table, so before I didn't had the entry for 23, right? Now I can see entry for 23 network via 12.0.0.2, which I only configured. And you see a yes here. Yes means what? Yes means static. And here you can see something called 1/0. This means 1 is the AD value, administrative distance value. If there are different ways to reach a destination and you see different AD values, in that case, to choose the best path, lowest AD is preferred. Lowest AD will be preferred, and that will be via 12.0.0.2. And this 0 is your metric. AD is 1, 0 is the metric. So if you see 100/30, then 100 is a AD, 30 is a metric. Both the informations we can see. Now I can ping. If I try to ping 23.002, the ping will go. Okay. This is called as your static routing. Okay. Let's talk about ARP. See, ARP plays very important role because whenever I'm sending some information, right, I need four information to send the packet. I need source IP, destination IP, source MAC, and destination MAC. See, these three information we have already. But what I don't have is your destination MAC. So in that case, I need to use R protocol to find out the MAC address of a given IP address. So ARP is a simple process where I need to find out the MAC address of a given IP. See, every device on the network has two addresses, right? We know it has an IP address and it has a MAC address also. So when one device like your computer want to send data to another device like a printer, it knows IP address but need to know the MAC address. So ARP steps in and asks here, hey, here is the IP address. Who has this IP address? We're going to ask you a question. This is called ARP request. ARP request means I will ask a question. Who has this IP address? For that ARP request, that device has to reply with ARP reply. When he replies now, he will reply using his MAC address only. So ultimately, I will learn that particular MAC address. So in short, ARP is used to find out the MAC address of a given IP address. And here we have ARP request and reply. ARP request, suppose a device, let's call that as a device A, want to communicate with another device called device B on the same network. Device A knows device B's IP address, but he don't know the MAC address. So device A sends out a ARP request, which is a broadcast message, meaning ARP request cannot cross routers and all. Okay. In this broadcast request, he will ask who has IP address, whatever it is. For that, they will reply back. So all devices on the network receives ARP request because it is a broadcast packet, but only device B will respond back because he is having the matching IP address. So when device B responds back with an ARP reply, this reply is the unicast message. It won't be broadcast because now I know who has asked me the question, right? So I will reply using unicast message. I'll reply using my MAC address only. The ARP has different types also, guys. One is called normal ARP. Normal ARP means when you try to find out the MAC address of a given IP address. If you go with the reverse ARP means ulta. It is used to find out the IP address of a given MAC. Proxy ARP means when someone else replying for the ARP request I have shared. Imagine PC1 want to send packet to server 1 and server 1 don't like to release his own MAC address. In that case, R1 will act as a proxy ARP. So he will reply back saying, hey, you can send the packet to me. I will forward that packet to my server. Like that we can tell. Then we got gracious ARP. Gracious ARP is simply used to find out the duplicate IP address detection, meaning in case you are trying to configure an IP address on the PC, and this PC also has same IP. Before this PC accepts that IP address, he will send out a gracious ARP asking everyone, hey, do we have someone with 10.111 IP? It is like it will ask everyone, anyone else in the network has MAC address for 10.111? It's also a gracious ARP only. So gracious ARP means just to find out the duplicate address detection and they will respond back. So in gracious ARP, both source and destination will be same only, guys. So next is your default route or default routing. See, sometimes when you want to reach a prefix in the internet, I told you in the beginning that a routing table should learn all the IP addresses to reach, should be aware of that IP address to reach that particular network, right? But what if in the internet I am going to have lakhs of IP address and I cannot learn all the IP now? So in that condition, what we can use it called default route. Default route is configured like this. In R3, I can go ahead and tell IP route to reach 0000 Next stop is 12.002. It is like telling R3, hey, if you don't find any matching destination IP address on the routing table, then send the packet to him. For example, if he sends a packet and he want to go to 37.001, it comes here. In the routing table, I don't see 37.001. Then I will match it with this IP and I will send it to him. This is called default routing. So when I'm not sure about what to do with that packet, you forward it to R4. So 0000 will match all the IP by default. Apart from if it is there, if entry is there in the routing table, then it is fine. If it is not there in the routing table, then only default route will be triggered, guys. So at last, talking about your routing table, here is your destination IP, how many subnets I'm having, how many masks I'm having. Again, destination IP, subnet mask in slash notation. Seventh is your AD value, metric value, next hop IP address, how long I have been learning that IP, via which interface of mine is used to reach that IP address. And this is like mnemonic code. Is it like C means connected, L means local, O means OSPF. Above this, you have a lot of alphabets that will tell you how I have learned that IP address. Okay. I want you guys to read this full form also right hand side. In case of any questions, please ping in chat. Thank you.